Hello guys, and welcome back to a new video. This video is on integration and it is part 2 of finding the area under the curve. So here we have two y values which are going to be our lines. So here we have the first one, the top line is going to be x squared plus 2 and the bottom line is going to be x squared. So we can write this bottom line as this. Draw it up like this. And this bottom line is going to be gx, as we've got two lines. Then on 2 here, we're going to draw our second line here. And this is going to be f of x. Perfect. So now we've got this graph set up. We want to find the area from 2 to 4, or this area here. Perfect. So our formula for two lines and finding the area between them is this. So it's the definite integral from a to b, still the same, but this time it's not by f of x, it is by f of x minus g of x, and then dx. So in this case, we want to find the definite integral from 2 to 4, and f of x is going to be x squared plus 2 minus x squared. Perfect. So here we can already simplify by minusing x squared from, okay. So that means that we can rewrite this equation simplified as the definite integral from 2 to 4, 2 as we have minus x squared dx. Great. Now the antiderivative for 2 is 2x, as 2 is 2x to 0. Great. The reason it is written like this is because x to the 0 is 1. So 2 times 1 equals 2. Perfect. So now with this 2x, we need to plug in our values, which are 4 and 2. So now this becomes 2, 4 minus 2 to the 2. So this is 8, 2 times 4, minus 4, which equals 4. So the area equals 4. Okay, so this is our next equation. Y equals 3x minus x squared. So we need to find the x-intercepts of 3x. So if we set y to 0, this can help us work it out. 0 equals 3x minus x squared. So that means, so we can factor this into 3 minus x, and that will basically equal this. Okay, if we set both of the things inside the brackets to 0, we get 0, but we also get this. 0 equals 3 minus x. This 0 equals 3 minus x is the only thing we really want to worry about, because this will help us find the x-intercept. So if we add x to both sides, we get this. X equals 3. So great. That means that x in this equals 3. X equals 3. Perfect. So, clean this up real quick. Okay. Now, this is negative x squared, which is a downwards parabola, like this. So, that means that we need to have a downwards parabola to x equals 3. So, we'll say this is 3 here. And then we get our downwards parabola, like that. And here we'll have negative 2. And if it is x equals 3, then that means that if it is x equals 3, that's the intercepting point. So that means that we have to get this. So that means that this angle will look like this. So what we want to find is this area over here, and this area, and this area. Great. So, to work this out, we use this. So the total area equals area 1 plus area 2. Great. Now we will call this area 1 and this area 2. But because this is going to be negative, as it is in the negative quadrant, that changes this. So the total area is going to be area 2 minus area 1. This is so that area 1 becomes positive. Great. So the formula for the areas is like this. The definite integral from a to b by the function of x dx. Great. So we are going to work out area 2 using this. So area 2 equals the definite integral from 0 to 3, and then f of x, which is 3x minus x squared dx. Perfect. So now we're going to get the antiderivative of this function. So that would equal 3x squared over 2 minus x cubed over 3. Great. So now we're going to plug in 3, 0, and 3. Great. Okay. So if we do this, it's like as follows. Then we'll plug in 3 squared over 2. Great. Minus 3 cubed over 3. Minus 0. Okay. So is going to equal 27 over 2 minus 27 over 3. So this will equal 13.5 minus 9, which in turn equals 4.5. So therefore, the area of area 2 equals 4.5. Great. So now all we have to work out is area 1. Area 1 is going to equal the definite integral from -2 to 0, and it is the function of 3x minus x squared. Great. So we plug it into the same antiderivative, 3x squared over 2 minus x cubed over, x cubed over 3. So then we have to plug in -2 and 0. Great. Now, this is going to equal 0 minus, remember this minus is like a -1, minus 3 times -2 to the power of 2 over 2 minus -2 cubed over 3. Perfect. So this is going to equal -1 times 12. It is 12 because -2 to the power of 2 is basically -2 times -2, which equals 4, positive 4. Because any negative number to the power of a positive number is, to the power of an even number is positive. It's 12 over 2 minus -8 over 3. So we need to work out the brackets first before doing it by -1, before timesing it by -1, sorry. So this is 6 over 1 minus -8 over 3. So we will just, to be able to simplify this, we're going to times 6 over 1 by 3 over 3. So this will give us 18 over 3. Now they've got the same denominators, so we can put that into the equation. 18 over 3 minus -8 over 3. So here we are going to get -1 times 26 over 3. The reason it is 26 is because when you minus a negative number from a positive, it's basically like adding. So this means that it equals -26 over 3. Perfect. So area 1, equals 26 over 3 negative. So negative 26 over 3. Great. So our equation that we were using before to find the total area was area 2 minus area 1. So area 2 is 4.5. So 4.5 minus 26 over 3. 26 divided by 3 over, minus negative 26 divided by 3. Negative 26 divided by 3 is negative 8.6 reoccurring. So we'll write this as negative 8.6 reoccurring. And this is what we get. So this will equal 16.16 reoccurring. Just wait and check this with a calculator. 4.5 plus 8.6. Sorry, that was bad calculations on my end. 13.16 reoccurring. So that is the total area right here. Thank you for watching. Thank you for watching today's video. I hope you can tune in again tomorrow. Tomorrow we are going to have a video for all ages. We are going to be doing one on algebraic equations, and then after that we will release a video on algebra first, and then we'll release a video on algebraic equations. So thank you for listening. See you next time.